Okay, so the last problem we're going to do is very similar to the previous problem, which was a graph. This one was all on a graph. The next one is going to be a table of values. But remember, nothing is different about this. These are still ordered pairs. This one is the same thing. These are still ordered pairs that make this line up. It's just we display it by a graph. This one we display it by a table. So like the previous one, we learned that as the as the height was increasing, the temp was decreasing. So this one, we have time and temp. And as you notice, as the time is what? Increasing, the temperatures are decreasing. So this one is the same kind of deal going on as you had on the previous one. So what you can determine here is that just like the other one, this is going to be a negative slope if we were to graph this line. The other thing to keep in mind when you have a table of values is these are your inputs, the time, these are your outputs. So this represents your x coordinates, this represents your y coordinates. So that helps when you're about to find slope or rate of change, because we're talking about this as rate of change because we are doing kind of real life problems. And we, instead of using the word slope, we call it rate of change. It's the same thing. You would still be finding, if you were to graph these points, you still would be finding the rise and the run to find the slope. But since it is a real life situation, it's a rate of change. So what's going on here is they've cooked a roast, and what they're doing is they're logging the times and the temp of what's happening to the roast the longer it's out. So when it was just out of the oven, this is when it was at its hottest. And then as the time goes on, then the temperature drops because it's getting cooler. So what we're trying to find on this problem is just rate of change, finding slope. Remember, rate of change is slope. And if you remember, slope was, if we use that formula, was change in y over change in x. So you can do the same thing with this table. So this first one, I'm doing the 0 to 10 minutes. So 0 to 10 is my x coordinates, 250 to 200 is my y coordinates. So remember, you do change of y first. So I can do 250 minus 200, and then I do my x coordinates, 0 minus 10. And then I see that 250 minus 200 is 50. 0 minus 10 is negative 10. And then if I reduce that, it's a negative 5, because remember, we already determined that this was a negative slope. It's like the one we did before. As the time is increasing, the temps are decreasing. Time increasing, temp decreasing. It was the same on this one. The height increasing, the temp decreasing. Same concept. So this would be a negative 5 degrees Celsius per minute. It's a decreasing change of 5 degrees Celsius per minute. The temp's going down, okay? The last one, they want us to do from 10 to 30. So what we're going to look at is we're going to see if our rate of change is going to be the same. So we'll go back to our table, and if we're going from 10 to 30, so we're going to do the 200 to the 100. So if we do our change in y's first over our change in x, so that's the 10 minutes to the 30 minutes. And then we do 200 minus 100 is 100. 10 minus 30 is negative 20. And then if I reduce that, zeros cancel, negative 5. Well, look, same answer, because your rate of change shouldn't be different. If it's a function, then your rate of change is constant. So again, as the time is going up, the temp is going down. It is decreasing at a 5 degrees Celsius per minute rate of change, which is the same thing, just another name for slope. It's more real world problems real world situations that we use the terms rate of change. All right, so that concludes lesson 3. So again, as always, you have an ALEKS assignment that you need to be completing. Thank you.